Imagine you're sitting at a campsite. The sun has just gone down, the air is warm and still, and normally right about now the mosquitoes would arrive. That familiar high-pitched whine closing in from every direction. But tonight, nothing lands on you. No swatting, no slapping, no reaching for the spray can. Around your camp, at roughly a 15 to 20 foot radius, the insects seem to hit an invisible wall. They approach, they veer off, and they don't come back. What you've installed costs less than $2. It has no batteries, no power outlet, no chemicals, no moving parts. It produces electricity directly from the damp soil beneath your feet, from nothing more than two different metals buried in the ground, connected by a single wire. This is called an earth battery, and it has a history that stretches back over 270 years, a history that was largely erased not because the science failed, but because the science worked too well for an industry that depends on you needing to buy something new every single camping trip. Segment 2. The Origin, Paris, 1747, Approx Doituin. To understand where this begins, we need to travel back to Paris in 1747. Jean-Antoine Nollet was court physicist to King Louis XV of France. He was one of the most respected scientific minds in Europe, a man who had spent years studying electricity at a time when electricity itself was still considered mysterious and borderline magical. Nollet set up a controlled experiment inside his stone laboratory. He took two identical pewter vessels and filled them with the exact same soil from the same source. He planted equal quantities of mustard seeds in both. Same temperature, same sunlight, same watering schedule. The only difference, one vessel received a low electrical current passed through the soil for roughly 10 hours each day. Within 3 days, the electrified seeds had already sprouted. The control seeds had not even cracked their shells. By the end of the first week, the electrified plants were visibly taller, with deeper and more developed root systems. But here's the detail that gets overlooked. The detail that went ignored for nearly 2.5 centuries. The insects in the laboratory avoided the charged vessel entirely. Small flies, gnats, and common biting insects congregated around the uncharged control pot. They showed no interest in the electrified soil whatsoever. Nollet published his findings in 1749. The agricultural world acknowledged them briefly. Then the observation quietly disappeared from mainstream science for generations. Segment 3, Alexander Bain and the Earth Battery. Edinburgh, 1841. Approx. 2 Entwemen. Nearly a century passed. In Edinburgh, Scotland, in 1841, a clockmaker named Alexander Bain was working on a problem that had nothing to do with insects at all. He was trying to find a way to power a clock without the need for traditional battery acids or external generators. His solution was elegant and completely unexpected. He buried a copper plate and a zinc plate roughly 1 meter apart in damp soil. He connected them with a single wire. When he measured the current flowing through that wire, he found approximately 1 volt of electricity, produced by nothing more than the chemical interaction between two different metals and the moisture naturally present in the earth. The soil itself was acting as an electrolyte, the medium through which ions travel to generate electrical current. The same basic principle that makes a lemon battery work in a school science experiment, scaled up and powered by the ground beneath your feet. Bain called it the Earth Battery. It powered a clock for months without any maintenance or fuel. But again, what happened around the buried battery was arguably more significant than the battery itself. Earthworms moved toward the space between the plates, apparently attracted by the electrochemical changes in the soil, and the biting flies that normally clustered around outdoor equipment. They left. 3 years later, in 1844, a Scottish landowner named Robert Forrester took this idea out of the laboratory and into a working farm near the town of Elgin. Segment 4, the farm results. Scotland, 1844-1845, approximately 130 Essek. Forrester installed a network of copper and zinc plates across his barley fields. He documented the results carefully and published them in the British Cultivator in March of 1845. The pest damage to his crops dropped to near zero. No aphids, no beetles, no swarms of flies at dusk. He described it as though an invisible perimeter had been drawn around his fields, a boundary that insects simply refused to cross. Edward Solly, a fellow of the Royal Society, reviewed Forrester's work and called the results remarkable. The scientific establishment agreed on paper, and then, once again, did almost nothing with it. Segment 5. The 1920s and the International Conference, Approx 1 min 30 sec. The Earth Battery concept continued appearing in the margins of agricultural science over the following decades. But it was in the 1920s that some of the most compelling real-world results were documented. A researcher named Justin, working in France, constructed tall antenna-style posts, roughly 25 feet high, wound with copper and zinc wire in a spiral formation. The idea was to extend the electrochemical field into the atmosphere above the soil. His oat crops grew over 7 feet tall with zero synthetic fertilizer applied. He reported that the current appeared to actively repel insects from attacking the plants. His fields were documented as completely pest-free without the use of any chemical treatment. And in 1912, at an international agricultural conference, scientists from across Europe gathered to present the accumulated evidence on soil electricity, electroculture, and pest management. The body of work was significant. The results were consistent across multiple independent researchers in multiple countries. The evidence was there. The science was sound. The technique was cheap, replicable, and required no external industry to support it. Then came the war, and then came the spray can. Segment 6. Why it was buried. The chemical industry. World War I devastated the farmland of northern France and much of continental Europe. In the aftermath, agriculture needed rapid, scalable solutions. Synthetic pesticides filled that gap. DDT was first synthesized in 1874, but became widely used as a pesticide during World War II. After the war, it was commercialized heavily. By the mid-1950s, it was being sprayed across entire landscapes. New organophosphate compounds followed, then carbamates, then pyrethroids. Each product had one thing in common beyond its chemistry. It needed to be manufactured, bottled, marketed, and sold repeatedly. A can of insect repellent lasts a few hours. Then you buy another. Every camping trip, every summer season, every backyard barbecue. The global insect repellent market now generates approximately $5.5 billion in annual sales, with around 82% of that coming from synthetic chemical products. Now consider the earth battery from the perspective of that industry. It costs under $5 to build once. The voltage is generated by the earth itself, replenished by rain, by groundwater, by natural soil moisture. You cannot patent two metals in dirt. You cannot brand the electromagnetic interaction between copper and zinc. You cannot sell a subscription to the soil. The earth battery repels insects. But more than that, it repels the entire commercial model that the pesticide industry depends on. That is not a conspiracy theory. It is basic economics. Research funding follows profit potential. Grants go to compounds that can be patented, manufactured, and sold at scale. A technique that costs $2 and cannot be owned by any corporation will never receive a major research investment, not because it doesn't work, but because no one profits from proving that it does. Now, it is important to be clear about what the science confirms and where genuine debate still exists. In 2015, a study from the University of Heidelberg tested the effect of copper on Culex pipiens and Culex quinquefasciatus, two of the most common mosquito species responsible for disease transmission. The results were definitive: 100% larval mortality within 14 days at copper concentrations as low as 1 part per million. That is 4 times below the World Health Organization's safe limit for copper in drinking water, meaning the water concentration that kills every single mosquito larva is still considered safe for human consumption. This is not fringe science. This has been independently replicated. Copper's effect on slugs and snails as a contact barrier has also been well documented in peer-reviewed agricultural literature. The Crop Protection Journal reported roughly 80% barrier efficacy in controlled trials. The electrochemical reaction between copper and zinc, the galvanic cell, is foundational chemistry. It is taught in every secondary school physics class. The earth battery is not a folk remedy. It is applied electrochemistry using materials that have been commercially available for over 150 years. Where scientific debate genuinely exists is in the specific question of whether the electromagnetic field generated by buried stakes repels flying insects at a distance of 15 to 20 feet. The historical evidence is extensive. The accounts are consistent across independent researchers on multiple continents. But that specific mechanism has not been tested under rigorous modern controlled conditions. The reason, as discussed, is straightforward. There's no funding incentive to run those trials. Segment 8. How to build it. Step-by-step instructions. Approximately 2 in 30 SEC. Here is exactly how to build and deploy an earth battery insect repellent system for a campsite. What you need? 14-gauge bare copper wire, 14-gauge galvanized zinc-coated steel wire, a wooden stake or length of bamboo approximately 3 feet long. Total cost at any hardware store under $5. Step 1. Take roughly 3 feet of copper wire and wrap it in a loose spiral around the lower section of the stake, working upward from the bottom. If you are in the northern hemisphere, wind the spiral clockwise. Southern hemisphere, counterclockwise. This orientation aligns the coil with the direction of the Earth's natural magnetic field rotation in each hemisphere. Step 2. Take 3 feet of galvanized wire and wrap it in the same spiral pattern alongside the copper. Both metals need to be in contact with the soil when the stake is planted. Step 3. Push the stake at least 6 inches into the ground. The critical requirement here is soil moisture. Moisture is the electrolyte. Without it, the galvanic reaction cannot occur and no voltage is produced. If the ground is dry, pour water slowly around the base of the stake before planting and repeat as needed. Step 4. Build 3 stakes using the method above. Place them in a triangle formation around your campsite, one near the tent, one near the cooking area, one near the fire or seating area. Each stake covers approximately 225 square feet. 3 in a triangular arrangement covers a full campsite perimeter effectively. Step 5. For any standing water near your camp, puddles, containers, water features, drop a short length of bare copper wire directly into the water. Based on the Heidelberg research, this produces complete larval mortality within 2 weeks, eliminating the next generation of mosquitoes from breeding at your site entirely. Once installed, the system runs continuously. Rain recharges it. You do not need to maintain it or replace anything. Segment 9. Real-world comparison, approx. 1 min. To put this in practical context, consider what the standard alternatives actually offer. A standard can of DEET-based spray costs around $12 and lasts a few hours. DEET is a compound developed by the U.S. Army in 1946 for jungle warfare conditions. It was never designed for recreational camping. It dissolves certain plastics on contact, including the coatings on rain jackets and synthetic fabrics. Documented side effects from excessive exposure include skin irritation, neurological agitation, and in rare cases, seizures. Regulators maintain it is safe at recommended doses, but the fact that it dissolves plastic while being applied directly to skin raises reasonable questions worth acknowledging. A citronella candle costs around $8. It requires you to remain in the direct downwind path to have any effect. It burns out within hours. DT wristbands lose their potency within 24 hours of opening. Natural essential oil-based repellents evaporate quickly, often within 30 to 90 minutes. Every single alternative on the market shares one design feature. It runs out. The Earth battery is the only method that does not expire, does not need refilling, and costs nothing after the initial $5 investment. Segment 10. The historical timeline and closing thoughts, approx 130 sec. Let's run through the timeline one more time because the pattern matters. 1747, Nollet observes that electrified soil repels insects in a controlled laboratory setting. Published 1749. 1841, Alexander Bain buries copper and zinc in damp soil, produces measurable voltage from the earth, and observes that biting flies leave the area. The Earth battery is born. 1844, 1845. Robert Forrester installs the system across working farmland. Pest damage drops to near zero. Published results confirm it. 1912. An international scientific conference presents accumulated evidence from researchers across Europe. The technique is validated in aggregate. 1940s, 1950s. DDT is deployed at mass scale during and after World War II. Synthetic pesticides become the industrial standard. The Earth battery disappears from mainstream agricultural practice within a single generation. 2015, University of Heidelberg confirms 100% mosquito larval mortality from copper at concentrations safe for human drinking water. The Earth battery was not disproven. It was not superseded by something more effective. It was economically inconvenient. The voltage is still there in every patch of damp ground on the planet. The copper still reacts. The zinc still conducts. The galvanic chemistry that Alexander Bain demonstrated in 1841 has not changed. 2 metals, wet dirt, 1 wire. No chemicals, no batteries, no brand name, no recurring cost. The Earth did not forget. The only question is whether we choose to remember. End of script.